In this video, I'll be trying to prove that the integral from 0 to infinity of sine of x cubed dx converges. So first, I'm going to split this integral into two integrals. The integral from 0 to 1 of sine of x cubed dx plus the integral from 1 to infinity of sine of x cubed dx. The first integral is convergent. Sine of x cubed is finite between 0 and 1. So if I prove that the integral from 1 to infinity of sine of x cubed dx converges, I've proved that the first integral we have also converges. Now I'm going to do substitution. I'm going to set u to be x cubed, then du would be equal to 3 times x squared times dx, which I can write it as 3 times u to the power of 2 over 3 times dx. So now I can write this integral, I'm going to call this a. I can write a as the integral from, when x is 1, u would also be 1, from 1 to infinity of sine of u du over 3 times u to the power of 2 over 3, which is 1/3 of the integral of 1 to infinity of sine of u du over u to the power of 2 over 3. Now I'm going to split this integral into two terms by integration by parts. If f of u is equal to u to the power of minus 2 over 3 and g of u is equal to g prime of u is equal to sine of u, then g of u will be equal to minus cosine of u, and f prime of u will be equal to minus 2 over 3 times u to the power of minus 5 over 3. Now I can write this integral as 1/3 times f times g, which is minus cosine of u over u to the power of 2 over 3 from 1 to infinity, minus the integral of f prime times g, which is the integral of 1 to infinity of 2 times cosine of u over 3 times u to the power of minus 5 over 3 times du. Now, this first term, as u approaches infinity, will approach 0. And it's finite when u is 1, so the first term also converges. And if I prove that this integral converges, again I have proved that the integral from 0 to infinity of sine of x cubed converges. So I only have to prove that I, which is this integral, the integral from 1 to infinity of cosine of u over, excuse me, this minus sign shouldn't be there, over u to the power of 5 over 3 du, I have to prove that I converges. So I'm going to introduce I prime as the integral from 1 to infinity of 1 plus cosine of u over u to the power of 5 over 3 times du. And you'll see in a moment why I did that. So we all know that 1 plus cosine of u is always between 0 and 2. Now, this implies that 1 plus cosine of u over u to the power of 5 over 3, when u is a positive number between 1 and infinity, is always between 0 and 2 over u to the power of 5 over 3. Now, there's a theorem in calculus which says that if some g of u is between 0 and some f of u, and the integral of f of u du converges, then the integral of g of u du, let's say from an a to b, this also converges. So we now know that I prime converges because the integral of u to the power of minus 5 over 3 is convergent, obviously. So I prime is convergent. Now we know that I prime, which is equal to the integral from 1 to infinity of du over u to the power of 5 over 3 plus the integral from 1 to infinity of cosine of u du over u to the power of 5 over 3 converges. And this guy, this integral here, also converges. So I prime, which is a convergent integral, is equal to another convergent integral plus I, the integral we have here. So I also converges. Yeah. Now we know that this integral converges, so this guy here converges, so A converges, so the integral from 0 to infinity of sine of x cubed dx converges, and that's it. I hope you guys enjoyed this video, and see you later.